Yeah, Andy. So I thought it'd be easier to go about this using the approach. I was saying at the point on the left of the center mass point, on the contact point. So I drew some pictures, and I guess I don't know how to quantifiable evidence. But it makes sense to me as long as dx, seeing as how far it moves over to the right, the contact point, is greater than dy, then it's going to be to the left. And I drew a couple of extreme examples. This one here where the dx is very small and dy is very big, and then actually the contact point would go wouldn't move very much at all to the right, and the center mass would move very much over to the right, causing it to fall over. And then another one where it's a very big dx and a very small dy, and I found that it barely moves at all. So yeah, that makes sense to me. So dx has to be bigger than dy for it to remain stable. Alright, Andy, take a bit of head scratching, but I think I got something here. So to keep the contact point to the left of the center of, or center mass to the left of the contact point, let's look at the problem this way. So it's going to tilt over. Sorry, see if we can. Just can't really zoom in on this, but oh, we can. So you can see. No, you can't. It's gonna. It turns on something spherical. It's gonna go. The contact point is gonna move right a dx, and which is obviously how much to the right it moves. And then, so I kind of do this diagram. You can see these lines right here. R1 is the normal center of mass from when it was horizontal, like up here. And then R2 is the new one, right? So I was thinking, I drew a little diagram here. I figured that it's going to move a degree theta, right? That degree theta is going to be dy over dx, dy being how much it moves in the y direction, dx how much it moves in the x direction, from where it started to where it is now. So that's how much the whole thing rotates, right? So this x down here, which is how far along the base, which is the same place the contact point is making, is going to be theta times r1, which is the length from the center of mass to the edge, which is halfway up for a rectangle, times sine of, so I can move over here, I can't zoom back out, of dy dx, so sine of theta. And that makes sense to me because I did this before just using dy dx, but it has to have the r1 in it because we know that something that's really short doesn't fall over as easily. It has a low center of gravity, low center of mass. And that makes sense in this because r1 would mean that it wouldn't move to the center of mass, it wouldn't move as far to the right along that base. So it would be more stable. So it would still remain left of that contact point. So this makes sense to me. I feel pretty good about this, but let me know. Thanks.